Today we'll start with Unit 3, Heat. Chapter 5, The Gas Laws. Lesson 1, Properties of Gases and Boyle's Laws. Particles of any material are moving in a continuous random motion. This type of motion differs according to the state of matter. So, the molecules of solids move in vibrational motion only. Molecules of liquid move translational and vibrational motion, and molecules of gas have random translational motion. We are going to study in this chapter gases. Properties of gases: Brownian motion, intermolecular spaces, compressibility of gases. In 1827, the Scotch scientist Brown discovered that the suspended pollen grains in water are always in a continuous random motion in all directions, as it's shown in the video. This continuous random motion in straight lines in all directions was called Brownian motion, after the scientist who discovered it. If we examine the smoke of a candle using a microscope, we notice that air-gas molecules move randomly in all directions. They collide with each other and the walls of the container, producing pressure. They will move in a certain direction through a short distance, then collide and change direction always. In this image we can see these short straight distances. When they collide, they change direction, and this is happening continuously. The reason for it is that gas molecules are in a free motion and continuous collision, or as we called before, Brownian motion. Intermolecular spaces. To prove that there are intermolecular spaces between gases, we make a simple experiment. We fill one graduated cylinder with ammonia gas, and then we invert it over another graduated cylinder which is filled with hydrogen chloride gas. The two cylinders are separated with a cardboard sheet. We remove the cardboard sheet, and when we remove this cardboard sheet, what we observe is a white cloud of ammonium chloride, which is formed at the center, then diffuses and grows until it occupies all the space within the two cylinders. Explanation: why did this happen? Ammonia gas molecules, low density, diffuse downward through the separating spaces between hydrogen chloride gas molecules and combine with them, forming ammonium chloride molecules. Hydrogen chloride gas molecules, high density, diffuse upward through the separating spaces between ammonia gas molecules and combine with them, forming ammonium chloride molecules. So all what we said explains that there are intermolecular spaces. Intermolecular spaces are large intermolecular distances which separate gas molecules. Compressibility of gases. Gases are compressible because the large intermolecular spaces allow gas molecules to get packed together when pressed. So, if the gas compressed, the large intermolecular spaces between its molecules decrease. Thus, the volume occupied by the gas decreases. As we see here in this image, here we have a great volume but low pressure. Here we have less volume but high pressure, because here, in the less volume, the distances between intermolecular spaces are decreased. The volume of a gas is affected by the changes in pressure as well as in temperature, or both, so that in order to make a full study of the behavior of the gas, we study the relations between variables which are volume, pressure, and temperature, which are known as gas laws. Gas laws are three. First one is called Boyle's law. Boyle's law relates the volume and the pressure at constant temperature. Charles' law relates the volume and the temperature at constant pressure. Pressure law relates the pressure and the temperature at constant volume. And general law of gases relates the pressure, volume, and temperature.